Okay, good afternoon to all of you. Can you all hear me clearly?
Yes, madam.
Yes, madam.
Okay, I think others, it seems that only 11 of you are here. So the objective of today's meeting is you asked me to give a revision. It's not like a revision class, but I think we will just try to revise what we have done, because this was dragged for a long time. We started the course two courses long time ago, but we could not continue as expected. I think I will share the first lecture we had, as I remember. Can you see the screen?
Yes, madam.
Yes. This is the the first lecture I did to you with respect to the advanced remote sensing and applications. The basic idea of advanced remote sensing and application course in this program is basically to direct you towards developing applications related to remote sensing. Since you have already followed courses, the introduction to remote sensing in your first semester, and now actually you are doing microwave remote sensing also in your first semester. In our previous program, we had 3 semesters. In the first semester, introduction to remote sensing. In the second semester, microwave remote sensing and advanced digital image processing, which is also related to image processing techniques in remote sensing. And then you are coming to advanced remote sensing and applications. At the same time, you are learning GIS technologies. You all know that spatial technologies, you can work together all the time. So once you learn the basics of remote sensing, then subsequently you can develop remote sensing based applications, and you can get the help of GIS to enhance those applications. So that is the basic idea of the advanced remote sensing and applications course, to develop real world applications. But I'm a little bit doubtful this time we could not go into much of the applications. But at least I want you to do some, at least one presentation of a real world application as part of your final year, final exam, like what you did in your first semester under the introduction to remote sensing course. You have to make a presentation based on an application of remote sensing in any subject area, but preferably maybe agriculture or natural resources management. You can prepare an application. Don't on a classification, but you can go into change detection or any other kind of advanced application and do a presentation that will be counted for your final exam. Part of the final exam. Okay, so with that, when we talk about the how to select and use remotely sensed data. Again, this slide is coming from your first semester. You have to identify when you want to use remotely sensed data. the very first thing is you need to know why you want to use this remotely sensed data. What are your goals and objectives? You may need to prepare a land use land cover map. For that case, it may be you need to do a simple classification, but sometimes you may need to identify the changes over time. For that, you need the change detection, and in some cases, you may need to identify the land surface temperature, like extraction of physical quantities, and sometimes you may need to identify biomass distribution, or maybe you want to identify urban expansion using NDBI like indices. Then you need to identify, calculate different indices, and sometimes you may need to identify very specific features like volcanic eruptions, and there may be very specific kind of characteristics in the landscape that you may need to identify. For all these things, we are using remotely sensed data. Then before we use remotely sensed data, actually nowadays remote sensing is a very commonly available source of data. Therefore, we don't have to bother too much. But sometimes the required data, whether they are available at our requirements, is a question, because all the required data are not free of charge. To obtain freely available data is not a big issue, but sometimes the freely available data sets like Sentinel or Landsat data may not be suitable for our application. We may need high resolution data. In that case, you have to think about it, whether we have some other options rather than using remotely sensed data. But if your choice is remotely sensed data, then you have to think about it and what are the other requirements. Like you can't work only with remotely sensed data that you know from the experience now. You need to do some amount of field surveying. In addition to that, climatic data like rainfall data you need, and again existing maps are required, and some technical reports, literature information is required to work with your data. Then when you use remotely sensed data, you have to have a thorough understanding about your data sets, which is lacking in most of the cases. So you need to know the sensor and the sensor characteristics, the bands available, the band characteristics, and the date of image acquisition, the atmospheric characteristics of the date, whether it was a rainy day or dry day, and general season of the year. So all this information is required because even the atmospheric has an impact on the quality of the image. The quality of the image has an impact on the data we extract from the image. So I skip this one because we are going to work with remotely sensed data. So this one also I skip because nowadays we don't need it very much. So then you have to develop your methodology. That is the most important section. I think some of you are struggling with your director study also, because developing a methodology is somewhat tricky, and sometimes it is little bit difficult, and you mostly try to do supervised or unsupervised classification. As I mentioned last time, you can go for some advanced techniques, like you can think of applying new methodologies like image-based, knowledge-based classification techniques. And there is another method, sub-pixel classification. Even though we have not applied, you can try it And ERDA's field guide will help you to do all these applications using their sample data sets. And while you are doing these things, you can see here, you need to check the rainfall data. If you are working with the land use land cover, cropping calendar is important to check. What type of crops are grown at that time period and the stage of the crop. At what stage, vegetation stage or maturity stage, need to identify these conditions. And then you have to arrange the field trips to go and collect field data. And you need to collect the most suitable band combinations. And working scale should be defined. Okay. So then what type of data analysis you are going to do, visual analysis or digital analysis. Certain other details are not very much required. And so this is about the data acquisition. This is also very much important, and when you are collecting data, you have to go to the data sources available. You can check the availability of the data in World Wide Web, and especially US Geological Survey's website, USGS website. When you go there, you can get registered, and most of the freely available data is listed there, and you can download the data from there. So that is one important source of data for us to get the data freely downloaded. So that is available, but in addition to that, if you can purchase the data, if you know the sensor exactly, you can visit the sensor's website and they will direct you how to purchase the data. So that is also possible. So this is about the digital globe to acquire data. So here you can see how you can acquire data. This is for spot image. Spot is another important satellite. It is the second satellite in the multispectral satellite. However, they do not provide free data. Therefore, we are in trouble of getting free data from them. Same satellite. And then this is the Indian Remote Sensing NRSA, National Remote Sensing Agency of India, Department of Space, Government of India. They also have a website and they also have satellites. However, they are not free of charge. Therefore, we are in trouble. So this is a very brief introduction about the importance of remotely sensed data when you want to work with them. And primarily, you have to identify the most suitable sensor or satellite. Then you have to check whether the data is freely available or not according to your requirement. If they are freely available, you are lucky. If they are not freely available, then you have to purchase the data. For purchasing, you have to find the suitable website, suitable sensor, and you can nowadays, I think it's possible for you to pay them and download the data. So that is one thing. Any questions related to this one? Anything? Okay, give me 1 minute. We talk about the change detection using remotely sensed data. Again, we did an exercise as well. You should know how to carry out a change detection, which you can do even in ADAS imaging. ArcGIS Pro as well, which is more familiar to you as I understand. So let's have a look what we discussed under change detection using remotely sensed data. So what is this change detection? It is the process of identifying differences in the state of an object or phenomenon by observing it at different times. So by observing an object, the state of an object at different time periods, we identify it as change detection. And multi-temporal datasets are used to quantitatively analyze the datasets in change detection. So that is the idea. So the examples are, there are many examples you can provide. So these are few examples that I have listed. Land use land cover change, forest vegetation change, forest mortality, defoliation and damage assessment, deforestation, regeneration, logging, wetland change, forest fire, landscape change, urban change, environmental change, and other applications like crop monitoring, etc. So you can add many more into this list. So in the change detection process, it should provide the following information. Spatial distribution of change types and change trajectories from what to what, how the changes are happening, from what to what these changes are happening. And also, we need to carry out an accuracy assessment of these changes. Otherwise, people will, our final accuracy is 100% when the accuracy level is relatively low. Therefore, accuracy assessment is also very much important. So let's look at the steps in change detection and assessment. Give me 1 minute. I will get some water. Okay, then the factors determining the accuracy of change detection. Precise geometric registration between multi-temporal images. I will ask some questions. What do you really understand by this? Precise geometric registration. What is it? Nandi?
Yes, madam.
What is the meaning of precise geometric registration between multitemporal images?
It means coordinates and the location.
Usually for geometric correction, usually for change detection, you are detecting the changes at the same location. So the images should be taken from the same location, and you know that to assess the changes, your images should be in the same coordinate system. So they are basic requirements. But it says precise geometric registration between multitemporal images. You need multitemporal images for change detection. So there are certain requirements, and this is one of the requirements for precise accuracy in the data, in the output. What is this precise geometric registration? Pilapitia,
Yes, madam.
what is the precise geometric registration?
When we are taking images in two different times, we should check whether the ground features match exactly and check the about the location and everything, madam. Specifically like ground condition and that weaving angles and everything.
How do you check? Actually, what is actually precise geometric registration means? You are close to that. We have to check. Anybody else? Neranji?
Remove the cloudy cover area.
No, cloud removal is something else. Geometric registration is needed. Image to image registration, I have mentioned about it. Image to image registration.
When we use the two different image, contrast image, it's actually some of the spatial resolution should be same in both image.
Yes, that is true.
So we should correct it both image spatial resolution before analysis.
Yes, that is true. We have
Madam?
to, yeah.
Madam, is it getting both images into same coordinate system or something?
Yeah, same coordinate system, but very precisely. That is the registration means exact matching of two images, location wise. Exact matching, pixel wise matching should be done. Otherwise, what will happen? Both should have the same pixel size. I think it's the same thing like when you are doing GIS overlay analysis, you have to have the same cell size. Otherwise, you can't do overlay analysis. And the cell by cell overlay you do. If they do not match with each other, the same location should exactly match with each other. Otherwise, what will happen? It will give you a complete erroneous output. Now, if somewhere else is matching with some other place in the second data layer, your output will be completely wrong. So therefore, precise geometric registration, place to place matching should be exactly happen between two or more images. That is called precise geometric registration, image to image registration. Usually what we do is we first geometrically correct one image and then we use that image to correct the second image, not the map. So image is used to correct the second image. So that is called image to image registration. That is very much important in change detection. Calibration or normalization between multitemporal images. What is it? Calibration or normalization between multitemporal images. What do you understand by that? There are also requirements of change detection.
Doing atmospheric corrections and do the normalizations for the images.
What do you mean by the normalization? Calibration or normalization. So when you are taking multitemporal images, usually what happens? Multitemporal data. They are taken at different time periods. Their atmospheric conditions can be different. Even if they are taken from the same sensor, their atmospheric conditions, lighting conditions, sometimes viewing angles can be slightly different. So therefore, they are creating different conditions in the image. In order to overcome the problems created, differences created by these external factors, you have to calibrate the sensor. Or you have to normalize. Normalize means you are bringing the values to a certain range. Normalize. So that they are comparable between different dates. Like when you are creating an index, then you can compare between different dates. But if you use the normal digital numbers, it's very hard to compare. So these kind of things also you need to think about when you are doing the change detection. So other things are easy to understand. Availability of quality ground truth data. You understand the meaning of ground truth. We'll ask from somebody else who usually do not answer. Vasanta, what is ගොඩක් දෙනෙක් නෑ වගේ. Vasanta, what is this ground truth?
Ground truth data mean, madam, it means real observed information collected directly from the ground.
Yes, the information collected from the ground. They are called ground truth information. Okay. The complexity of the landscape and environment of the study area, that is also important, because if it is too complex, it's very difficult for us to get an accuracy. Change detection methods and algorithms used, you can understand about it. Classification and change detection schemes, analyst skills and experience, knowledge and familiarity of the study area, time and cost restrictions. All these things will depend on the level of accuracy. Okay, so that is something very simple. So change detection, again, as I mentioned last week, you can detect the changes before doing an image classification. Before you are classifying an image, you can do the change detection for raw data layers, and you can then develop indices and compare the indices between multiple dates and do the change detection. Or else, the most convenient way for us to understand the final output is to do the classification, post-classification change detection. After classification, you assess the changes. So there are different ways to apply these changes. So you did this change detection as a practical as well. I don't know whether you can remember it or not. Can you remember? I think most of you can't remember it now, but you did it as a practical, and we spent about 2-3 weeks on this exercise. Okay, so think about it, get an idea about change detection. Very specifically, post-classification change detection, how to carry out a post-classification change detection. I'm just trying to show you what we have done. Think I have shown you this presentation as well as an example to show you how to develop a study as well. I don't know whether I have done this under advanced remote sensing and applications. I think probably it was under that subject. The one of the final year student presentation based on heat island formation in Colombo City. So importance of vegetation to reduce heat island formation in urban areas in Colombo City. So we will quickly go through it. So in this study, the basic objective is to develop the land surface temperature information using remotely sensed data, but not to stop there, but to develop a study to show that remotely sensed data can be effectively used to identify the urban development and as a consequence how the land surface temperature is increasing, and then how it has an impact on the urban environment. So this can you see the slide?
Yes, madam. Yes, madam.
Okay. So I don't want to go through all this information, but in general, the slide gives you an idea about the impact of urbanization on the surfaces. And so with the urbanization, soft land cover classes like green areas and water will convert into hard land cover types like buildings and tarmac surfaces, etc. And this leads to urban heat island formation. And when the urban areas have high temperature areas, so heat islands, it will eventually reduce the working capacity of the people, because you can see reduced work efficiency, electricity driven heat regulators are required, and so power requirement will also be increased, and then water quality will also be reduced, because runoff temperature will be increased, because a lot of heated water will be released into the water bodies and reservoirs. So actually this study is primarily looking at the possibilities of increasing the green spaces in the urban areas in order to overcome this heat island formation effect. So, but I want to show you how these heat islands are estimated and identified in an urban area. So, the study was conducted in Colombo City. These are the objectives. You can see that when we are writing the objectives, good for your director study report as well. To explore, to assess, to identify, to analyze, these kind of words can be used. To identify, even not good, to explore, to develop, these kind of terms are ideal for objectives. So think about those as well. So the data and material, satellite images of Colombo City. At the time, Landsat OI data were not available, and Landsat TM images were used, and land use land count. As I mentioned earlier, it is hard for us to work only with remotely sensed data because additional information is required, and Google Earth images were required, and electricity energy consumption data of Colombo City. The attempt was not very successful, even though, but it was also required. Rainfall and temperature data of the study area. So in addition to remotely sensed data, more additional data were required in order to support what we were doing for our area. And this is the methodology. Landsat TM and ETM plus data. You can see the methodology for remote sensing was supervised classification. But in your studies, you can think about improving the classification accuracy by incorporating new methods like ETM plus, new methodologies like knowledge-based classification, and I don't recommend subpixel classification, but even object-oriented classification if your data is fairly high in spatial resolution, and if it is for a smaller area, smaller urban area. And for Colombo, there were mainly vegetation built up and water was identified, and For the temperature, urban heat island areas and other areas were identified. To calculate the urban heat islands, a small equation was used to separate the urban heat islands from the other areas. So accordingly, you can see in 2001 and 2005, this is one-time data. This is the other limitation, because again, I hope you have done land surface temperature estimations using with Ajit sir, and he also must have told you that temperature is a changing variable. Therefore, you can't work with one or two data layers. You need more data to represent varying rainfall conditions. However, we face the problem of cloudiness in the data. Therefore, we had to restrict it to two data layers. However, rainfall temperature is a changing parameter very much. Data set may not be very much appropriate, but this is the situation at that particular time period. And the land use map is like this. According to the land use map, you can see the land use percentages. And the authors have identified the problems also, the presence of mixed pixels, because the sensor use was ETM plus primarily. So the sensor characteristics are not adequate to capture this spatial variability, and there were many mixed pixels present in the borders between vegetation and non-vegetation, vegetation and built-up areas like places. So therefore, it was a problematic situation. And all information extraction and reference information collection from the ground, there was a gap. So that also may have led to some erroneous information that we have collected as correct information on the ground. So what is NDBI? What is NDBI?
Normalized difference vegetation index.
NDVI is normalized difference vegetation index. NDBI.
Normalized difference built up index.
Normalized difference built up index. What is NDWI?
Water index.
Yes, normalized difference water index. So this normalized difference is common to all three indices listed here. Normalized difference vegetation index, normalized difference built-up index, normalized difference water index. So they are always normalized difference. They get a difference and normalize by dividing it with the summation of the bands we use to get the difference. Therefore, they come to a value range between -1 to +1. So they are normalized indices. So they have a fixed value range. So they are suitable to assess the changes because we have fixed their scale. So you can easily compare. So NDVI, NDBI and NDWI. I hope all of you are capable of answering this question because I asked you to identify the indices available to work with remotely sensed data and summarize them. Did you do that? So these circles show actually NDWI did not provide very good results, so we did not consider it for further assessments. So NDVI and NDBI, you can see a difference. NDVI, when it is low, dark color is low. NDBI is high. The vegetation built up is high and NDVI is low. They have a negative relationship. Again, you can see in other place the NDVI is high, NDVI is low. That area. So the student has identified specifically in specific areas in Colombo metropolitan area to identify these values. And again, I hope you manage to extract. Can you get these kind of values and develop graphs if you are asked to do it? I think you have done this with Ajit sir. Did you do it? Can you do this kind of graphs like is it possible? Yes or no? Chintana? Can you extract some NDVI pixel values and produce graphs like this? In the sample, the pixels and NDVI values?
Yes, madam.
Is it possible?
Yes.
Yes, you should be able to do that. Plotting them in Excel sheets, so it should be possible for all of you. So what do you think about this 2005 image? It's little bit blurred compared to 2001 land surface temperature image. What is the difference? Why it is different from 2001? This is Landsat TTM Plus in 2005. In 2001, it is Landsat TM thermal band. Nishanka? Yes, Nishanka?
resolution.
Yes, the spatial resolution, pixel size. I think in Landsat TM it's 60 meter pixel size in thermal band. Sorry.
Yes, madam.
Yes,
60 meter in ETM plus, I think 100 meter.
Yes, in 2005 in ETM plus it is 100 meter pixels. So comparison is not good with different pixel sizes, but it was the data that was available for us to use. So the locations are showing. Okay, so again a similar graph, relationship between land cover and land surface temperature. You can see again, you can draw the graphs now between different indices and land surface temperature. And you can see with NDVI land surface temperature produce a negative relationship when the normalized difference vegetation index or the vegetation cover is higher, getting higher, the land surface temperature is reducing. That is obvious, we know. And the normalized difference built up index, when the building density is increasing, the land surface temperature is getting increased. So that is good for the validation purposes. So I think I don't want to go for this part because, but you can incorporate this kind of information to make it a study. The impact of land cover on energy consumption. Actually, here there is an issue because from the remotely sensed data, what you can see is the buildings only, but the building characteristics are difficult to obtain, whether they are multi-story buildings or not. There are mechanics that you can do, but we could not do. So as a result, it was very difficult to identify the nature of the building and their electricity consumption. Therefore, we made an attempt, but it was not, I should say, not very successful. But as a study, this is a fairly good study. So this is to show the proper land use planning and how the land use planning has an impact on lowering the temperature. There are two sides, and vegetation cover strength when it is high. Site 2 is having more green environment. Site 1 is having more built environment. So the green environment is site 1 is having without green, site 2 with green environment. So NDVI in site 2 is higher compared to site 1. So NDVI in site 2 is in blue color, it's relatively lower than site 1. And land surface temperature in site 2 is relatively lower than site 1 because it has more vegetative cover compared to site 1. They are located very close to each other in Colombo city, but they have different level of green environment. Site 1 has less green environment compared to site 2. So this also confirms that the green environment facilitates to reduce the land surface temperature. So you can think about a study rather than a practical exercise. When you are developing a study also, you can think of advanced remote sensing and application. So we have not done big advanced studies, but you can make it more advanced by incorporating sections from different parts so that it will become an advanced study. Okay. Okay, so I will just, so these are some additional slides students usually keep. So surface covers instance extraction band mathematical operations. This is something I asked you to do also. NDVI is a common index, you know. NDWI, red minus near infrared divided by red plus near infrared. Built up area, middle infrared minus red divided by middle infrared plus red. These are some additional information. Okay. So this is, I think we have not done this one. Image processing, information extraction, spatial filtering and classification. We have done classification. So we have done information, image processing and information extraction. So this is not from mine, actually it's somebody else's presentation, but it says about spatial filtering and classification. So I thought of just giving you an idea about spatial filtering through this presentation. So when you think about spatial information, I hope you are familiar with spatial interpolation. We are doing spatial interpolation with the idea that things close together more alike than things further apart, which is in spatial statistics also we identify it as spatial autocorrelation. Things close together more alike than things further apart. And many features of interest have spatial structures such as edges, shapes, patterns, like roads, rivers, coastlines, irrigation patterns, etc. And have you ever heard about spatial filters? Have you heard about spatial filters?
No, madam.
Sorry, you have not heard about spatial filters. You have not applied spatial filters? Neranji?
No.
No. How about Danshika?
Madam, madam, is image processing also spatial filter, right?
Image processing is not a spatial filtering technique. In microwave remote sensing, definitely you must have used spatial filters. Speckle reduction filters, did you use? Can you remember microwave remote sensing practicals? Speckle, can you remember speckle? You have not used in microwave remote sensing. Salt and pepper appearance in microwave remote sensing images, which are called speckle.
Yes, madam.
Huh?
Yes.
Yes, to reduce the speckle, you have to apply filters. You have to apply filters to reduce the speckle. Okay, so I will give you an exercise. So classify an image and apply a filter. Filters are available in, I think they must be available in ArcGIS Pro as well. You have both ADAS and ArcGIS. So apply a filter. Do a classification and apply a filter and see what happens to your image. Okay, so filters are important because when you use a filter, what is the purpose of a filter? We use water filters. We use filters kind of, let's say, we use how do I say, sieves are kind of filters, sieve to sieve certain things. They are also kind of filters. The part of the thing will go through the sieve and part will retain. Bigger particles will retain, small particles will go through depending on the size of the sieve or the filter. Okay, so we are using filters to retain some information and pass some information. So spatial filters divided into two broad categories. Feature detection filters are there, edge detection filters as an example, and image enhancement filters like smoothing, speckly filters like radar images, smoothing filters like speckle reduction filters are smoothing filters that you have used. If you have done microwave remote sensing practicals, I know that sir did some practicals, even though you can't remember. So they are called smoothing filter. Remember them. So in our data sets, you can see if you have pixels close by, the pixel colors, shades are like this. Gradual changes are there. Frequency is low. We said it low frequency. But in the second image, black to white, there is a drastic change. The color is changing, digital number is changing very quickly. Here it's a gradual change, not a big, actually change is not happening also here. Light and then again gradually change. But here it is going like this, it remains like that. High frequency change. So these kind of incidences are happening. Spatial filters highlight or suppress specific features based on the spatial frequency. So the idea of spatial filtering is to highlight these characteristics depending on these high frequency or low frequency characteristics. So here you can see DN values are from here to here. Rough change 189 to 51. They are changing from 189 to 51, rough change. But 189 to 210, smooth change. Rough change, rough means rapid changes. Slow change or no change, smooth change. So both changes can be highlighted using these filters. So you can see brighter horizontal linear features because pixel numbers are large numbers, they are bright pixels, and when the pixel numbers are smaller, they are darker horizontal linear pixels. So this is how a filter is working. You are asked to develop a filter window. You can develop a window by 3 by 3. Means you can have 3 by 3 cell window. Altogether 9 cells. Or 5 by cell, 25 cells. Or 7 by 7 cells, 49 cells. So compute weighted average of pixels in movie window and assign that average value to the center pixel. So what we do is we keep the moving average, we keep the kernel that here and get the average value of all these pixels and put the average value to the central pixel. And we shift the kernel here. Get the average of all the pixels and give the value to the central pixel. So likewise, we smoothen the pixel value. So that average value will be put at the middle. And also choice of weights determine how filter affects the image. So now what you are getting is very average value image, because what you are doing is you are getting all the values and get an average and put it into the middle cell of the filter window. So ultimately you are getting an average value. But sometimes you can give a weight to the cell window and multiply it by this weight. By that you can increase the cell value. That is also possible. So think about it. I can't tell you how to do it now. Now it's something like this. So this is the filter. This is the input image. So you place it here once. And the middle pixel, you multiply these values by 1/9, 1/9 and then add them, and the central pixel will get the average value of all. And then you move the kernel to here, shift it and shift it again. Likewise, you cover the entire area. Something like this. You can see for first pixel in output image, you can see the value. Mean filters are known as low pass filters, allow low frequency information to pass through but smooths out high frequency, rapidly changing DN values. High frequency from data. Opposite is high pass filters. Used to enhance high frequency information such as lines and point features while getting rid of low frequency information. So high pass filters are used to enhance high frequency information. You can see all the other values are minus, but the middle value is higher, so that you enhance the middle value. That is middle value is enhancing. So there are different type of filters are available. Can also have directional filters. Like you can see here towards this direction, -1, 0, +1. So the filter is moving towards one direction, -1, 0, +1, this direction. Vertical edge enhancement filter, horizontal edge enhancement filter. So likewise, you can see different type of filters available. So what I can say is like even though we did not practice, usually we can design practice. I don't want to say we have not practiced, even though I did not practice it with you. Definitely you have practiced it with your microwave practical classes. So try it once again. It should be available in your ADAS Imagine software. So you can see low pass filters, smoothen image. So this is the original image, and you can see the smoothen image as a result of low pass filter. And edge enhancement, if you really need it, you can apply. So you can see the edges are enhanced as a result of high pass filter. Okay, so that about filtering. And I think image classification, we have already done it. And you know about digital numbers are used for classification, and you are familiar with supervised classification. And this is a scatter plot. you know how to draw a scatter plot, and these are different spectral signatures or training samples when you plot them using two bands at a time. And sometimes you can see some pixels are very close to each other in training samples and some are far away, like water in this example. Water is easily separated, but corn and hay are very close to each other. Urban and sand. Urban is a very diverse, dispersed training sample. So likewise, when you are collecting training samples, they are having different issues. And classification can be carried out using different classification algorithms. We are using mostly maximum likelihood classification because it assumes that the pixels values are normally distributed and it utilizes the statistical information available in the data, but there are some other classification algorithms available as well for the classification process. So these are some of the minimum distance to means classifier, and this is parallel piped classification method. This is again a parallel pipe classification system, and this is the maximum likelihood classification. And these are the probability density curves developed using maximum likelihood classification. And unsupervised classification is something that again we discuss its advantages because you don't have to bother about selecting training samples. It's very straightforward, but it has its own disadvantages as well. And you have done already unsupervised classification. And this is where this filters are effective. Post-processing of the data that you have not done. Ideally, all classes would be homogeneous. When we classify an image, all the classes, the categories that we have obtained after classification would be homogeneous. In reality, we get weak pixels misclassified as P's, etc. Accuracy is less than 100. We know that misclassifications happen. Then it's advised us to pass a majority filter over classified image. As an example, 3 by 3. 3 by 3 cell size majority filter assigns output pixel value to be majority of nearest 8 pixels. So as an example, when you see like here, your input image would be like the first one. The majority pixel filter when you pass your output, when there are small cells, then output pixel values to be the majority of nearest 8 pixels, then it will smoothen out your output, which is an advantage. So it will be a smooth output so that you can see the advantage of applying a filter to your classification output. So you can try that one to improve your classification output. Okay, so this is one more thing that we have not done as a practical, but we can try it and see how it comes out. Okay. Do you have any questions related to there are many other things we talk about one other thing. Practically, I think we did not do one other thing. I don't know whether we did it or not. It's coming under image enhancement actually. Pan sharpening. Have you heard about pan sharpening?
Yes, madam.
Yes. What is pan sharpening?
Pan sharpening, we use different spatial resolution images to enhance the image.
Means
Different in spatial resolution to images.
different spatial resolution means, can you explain, because it is it's somewhere very special condition.
In a same area, should be same area.
Same area, yeah, you have to have a same area image, but it is very special.
It's like in Landsat, 15 meters is the panchromatic band resolution. Other bands are 30 meters, then we can
Pan
use
sharpening, and yes, in the same satellite system. Can you give me 1 minute? Okay. Hand sharpening means, you all know that nowadays in almost all the satellite systems, we have multispectral mode as well as panchromatic mode. What is this panchromatic mode? What is this panchromatic mode? Is the panchromatic mode? Neranji?
Yes, madam.
Panchromatic mode. In satellite systems, you have multispectral mode and the panchromatic mode. There are two different modes of operation. Sorry.
Black and white, madam.
Yes. Grayscale 1. Ishani, what is the multispectral mode? Take an example. Take Landsat OLI and explain it. Ishani?
All bands.
Lahiro?
Madam, satellite image capturing the electromagnetic spectrum, like
Yes.
yeah,
But what are these two modes of operation?
sorry, madam.
What are the two modes of operation in the same satellite? At the same time, suppose they are taking an image over the Kandy area, University of Peradeniya. They take a multispectral image as well as a panchromatic image. This is first semester work. So what is the meaning of panchromatic and what is the meaning of multispectral?
Panchromatic mean, madam, they capture all visible range spectrum.
Yes, in one band.
One band, one grayscale band. Yes.
Grayscale band. Multispectral means?
Specific band. It's mean the electromagnetic bands like near infrared.
Yes, they get multispectral bands. Multi means many. Many spectral bands. According to the sensor, there may be 3 bands, 4 bands, 5 bands, 6 bands, 7 bands, likewise. They produce multiple spectral band images. So that's what it says. Depending on the satellite sensor, you know that nowadays in Landsat OLI, there are 11 spectral bands, and Sentinel, it has, I can't remember, again 11, 12 bands, and depending on the sensor, multispectral, they have number of bands. But this panchromatic, they have only one band to cover almost the entire visible region. So since it covers only one band, it's a black and white grayscale band. So what is the special character of this band? It has low spectral resolution because it has only one band. But what is the spatial resolution? Lahiru? Spatial resolution? Nishankar?
The spatial resolution is high than multispectral.
Yes, spatial resolution is higher than the multispectral because it has a higher bandwidth, energy is higher. Therefore, comparative to the multispectral region, the spatial resolution is high. So we get the advantage of high spatial resolution from the panchromatic band and high spectral resolution from the multispectral band, and combine them together to get a high spatial and high spectral resolution image. So that is called pan sharpening, sharpening the pan image with the multispectral data. That was very common some time ago, but nowadays we don't do it because now we have some good high resolution data available. But about 20 years ago, the data were not available, therefore this was a common practice. Now it is not very common. But just keep it in mind. I think what I understand from you is actually please read your first semester notes. They are very much important for you because they are basic remote sensing. Without basic remote sensing, you can't go to advanced remote sensing. And you have to have some idea about microwave remote sensing also, even though you do not apply it very much. So without knowing the basics, you can't go to applications. Your problem is you can't remember the basics. You can't even remember the multispectral term multispectral. So then how do you go into advanced remote sensing? Advanced is advanced, the next level. You can't go into advanced without knowing the basics. So therefore, please read your basic notes because in your exam, I am going to give you a practical exam as well as I will give you a small theory exam as well. Or else I will take a Viva exam from you. That is easier for me because I don't have to go through the papers, but I can directly intervene with you, even though it takes time. So I will think about something. I will prepare a set of questions and I will go for a theory Viva exam. For that, I will check your knowledge on. So you have to be familiar with your familiar. That will help you to get ready for the comprehensive also. So therefore, please be ready with ready with your notes, especially your first semester notes. You should know at least about few sensors and their characteristics, general characteristics. You can't say you don't know about anything. You should know about spectral signatures. You should know about very important sensor characteristics. So the general, at the end of all these courses, if you do not show any signs of uh, student who have followed many courses related to geoinformatics, that is not a good sign. So show that you have some idea about geoinformatics. You have followed so many courses, now you should have some idea about these subjects in your mind, because you have heard at least many things again and again and again. When you are at home, there are so many YouTube videos available on these basics and everything. So you just put them in your computer, and then while you are working on other things, you just put them. Don't listen to music nowadays. You listen to these videos. They will help you to learn. So at least you will hear these words and you will learn these things. Don't listen to unnecessary. These are the things that are very much important for you. So that will help you to learn things. So much of material available that will help you to learn. I think that is the ideal thing. Listen to these videos, YouTube videos, and there are very nice webinars going on. You can listen to them. The potential applications are there. I also listen to some of these things, and you can listen while doing some other work. Household work, you can listen easily. Then you will get familiar with the terms. All these terms you will get familiar with. That will help you to face the comprehensive easily. So these 2 months are crucial for all of you because you want to finish early. So therefore, get familiar with the terms, and for that, get ready for the exam. Okay, so I will stop here. And if you have any specific questions, you can ask me at any time. And actually, it's very hard to cover. There are so many things we can discuss, but very hard to cover everything. But in general, get a general understanding about these subjects. So as I said, I will try to give I will give you 2 different exams, because I should cover 2 different subjects. And also for the advanced remote for both subjects, I will give vivas, or for one viva, one small exam also. Maybe for digital image processing, I will go for a viva, because for the advanced remote sensing, I have given you some assignments. The other thing is, for everybody, please send the assignments that I have asked you to do. And the last one is spatial filtering. You can apply a spatial filter, and if you like to send it, please send it back to me. Any other questions? Anything else? කතාවත් කරන්න රංජිත් sir කියනවා වගේ. Ranjit sir's class will be held tomorrow online, because no way others came here today, so you are not here, he couldn't take the class. So tomorrow at 10:30. Okay, so please be there for the class.
Okay, madam.
Okay, then I will stop here and I will inform you the exam date.
Okay, madam.
Okay, thank you for joining.
Thank you,
Only
madam.
of you are here because I can see Vasanta twice. Vasanta twice. Nishanka, Lahiru, Dhammika, Vanninayaka, Bimsara, Veerasurya, Ishani, Niranji, Chintana, Pilapitiya, Nandi. Only few of you are here. Some others are missing. Okay, anyway, doesn't matter. Okay, thank you.
Thank you, madam.
Thank you, madam.
Okay,
Thank you.
okay. Thank you.